everybody. Welcome to Database World at CloudWorld 2023. This is the session about application observability with enhanced diagnostic and OpenTelemetry integration. My name is Kouassi Mensah. I do product management for Oracle, and with me is
Alex Key, and I also do product management for Oracle.
Thank you, Alex. Here's the day's agenda. Observability in Oracle Database 23. Diagnose on first failure. And then Alex will present the OpenTelemetry and dynamic and secure tracing. So observability in Oracle Database 23C. Observability refers to monitoring, capturing, analyzing logs, metrics, and traces. Those are the three pillars of observability: logs, metrics, and traces. So your goal is you want to be able to diagnose issues in real time. And this is a crucial requirement for modern application. Take microservices, for example. You have a microservices-based application, which is a multiple microservices, and you have to diagnose some performance issue or trace issue. How do you do that? So that's the purpose of observability, is to allow you to do that in real time and be able to diagnose where things is happening in a very complex and distributed system, whether it's in the development or deployment, DevOps, SecOps, etc., etc. So the Oracle Database 23C furnishes for Java, .NET, and other programming languages new and enhanced observability features. And that include diagnose on first failure, enhanced logging, distributed tracing with OpenTelemetry, dynamic and secure tracing. So we will cover some of those in the next slide. So diagnose on first failure. This is a feature which allows you to diagnose as soon as an error or a failure occurs. So for example, you are running your Java application and you got an exception. Well, you will get a dump of the memory where we record all the critical execution state. And we call this the ring buffer. So we dump the ring buffer on the diagnostic output, and you can analyze. So it gives you all the details you need to diagnose the problem. It is on by default, but we allow you to disable if you wish to. And to do that, you get to use the system property Oracle JDBC diagnostic that enable diagnose first failure equal false because it was true by default. Or you can use a diagnostic mbin for managed bins. So you can use the message bins interface to disable that. Okay, to accompany that, to support that, we've also made changes to the behavior of our JDBC drivers. So in the past, we have 4 categories or sets of drivers. We have what we were calling the production drivers. For example, those are OJDBC 8.jar for JDK 8 compatible, or OJDBC 11.jar for JDK 11 or compatible. And this was used only for production. For debug, you got to use OJDBC 8_g.jar or OJDBC 11_g.jar for debugging. And if you want to get metrics, you need to use OJDBC 8dms.jar or OJDBC 11dms.jar. And if you want to debug the metrics, you got to use OJDBC 8 DMS underscore G.jar or OJDBC 11 underscore G.jar. So the good news is in DB23C, to support observability and diagnose on first failure, the production jar, namely OJDBC 8.jar or OJDBC 11.jar, they work for production, debug, and metrics. And so as you will see in the demo, by just using the production jars, we were able to get the diagnosability debugging information when a failure occurs. So that's a summary of how diagnose on first failure works. And now let's go to the demo. This is a two-part demo. We will see a Java code running with diagnose on first failure enabled, and the same Java code with diagnose on first failure disabled. Right, so let's look at the code. This is the JDBC URL, and this is the connect string. We're connecting with Scott Tiger, and we have the URL as part of the connect string. Then this is the prepare statement. And as I mentioned, this is a very basic. We are just selecting user from tool. Then we are printing her here, the user. We are killing the session. And if there is an exception, we print the stack trace. Right, so let's execute this code with diagnose on first failure enabled, and the same thing by disabling diagnose on first failure. This is running the JDBC 23C as is. When you get the JDBC 23C, diagnose on first failure is enabled by default. So it prints a lot of stuff, but what is most important is what is printed when with diagnose on first failure, when it dumps the ring buffer. So we can see the properties, a lot of properties, right? Properties. And then we will see the Java library path, okay, Java class path. This is the Java version, and you can see we're using Java 11. And this is the JDBC URL. And then we see the exception, and this is a stack trace. Okay, let's see the same code disabling the diagnose on first failure. So we execute the code, and here, as you can see, only the stack trace is printed. We have the user printed, all right? But this is the stack trace that has been printed, right?
Thanks, Quasi, for that demo on first failure capture. I'm going to talk about OpenTelemetry. Now, what we've seen in recent years is a lot of adoption of microservices, multi-cloud, and serverless. And from that, we are getting a lot of ways we have to diagnose all these different um, small services together, integrate all these different services, and it has been a challenge for a lot of developers and DevOps to be able to do that. And that's where something like OpenTelemetry comes in. With OpenTelemetry, what we have is a way to unify and the observability framework so that you can have all these many numbers of just operations going on that are independent of each other, and be able to collect all that in an easy way so that it can be consumed and it can be analyzed. And that's one of the great things about OpenTelemetry, is that it's an industry standard. It is supported by Oracle and many other vendors, and all this telemetry data can be unified in a single place so that you can use tools like Jaeger or even a console app to be able to, or Zipkin to be able to analyze it, and it's free. And it's also supported by Java and .NET as well. And importantly for us in this talk is that Oracle JDBC and Oracle Data Provider for .NET is supporting it so that you can collect those traces and that telemetry data and be able to see how it operates within the greater system that you're using. So with ODP.NET OpenTelemetry, I'll talk about that first. That supports just within the standard framework of .NET's OpenTelemetry support. And we make ODP.NET OpenTelemetry available on NuGet. So you can get it in NuGet Gallery. You can use it with the managed driver or the ODP.NET Core driver as part of the 23C version. And that 23C version can work with Oracle Database 19C or higher databases. And it just plugs in right into .NET's OpenTelemetry framework. So what you have is you have this activity source that then will create and start activities, activity objects, and then your app will then stop and start these activity objects around some meaningful unit of work. And that meaningful unit of work is called a span typically, but in .NET parlance, it's an activity. They call it an activity there. So ODP.NET itself will internally open up a .NET activity source, and that will measure common operations in ODP.NET, things like your executions of SQL statements or your round trips or your filling of data to retrieve data. So all those are something that ODP.NET provides you in our NuGet package for OpenTelemetry. And you'll see that it captures all those in common methods that we're using for those executions, things like execute reader, execute non-query, filling with a data adapter, reading with an Oracle data reader. So nothing unusual. This is very typical for ADO.NET, and you'll see that with ODP.NET itself. And we also will measure round trips, because you'll want to know, is one of the things that we've seen customers do is they want to know, well, how long does my SQL take? So that will be captured by our OpenTelemetry implementation. So what data are you going to see with ODP.NET OpenTelemetry? Well, you'll see the standard data of different activity attributes, and on the left you see those attributes, and on the right you'll see the sample values that you might experience as you use ODP.NET OpenTelemetry. Something like activity source name, you'll see ODP.NET in there. The display name will see the operation occurring. In this case, it's an execute reader. And ODP.NET itself has exposed specific activity tags, and you'll see in there the database type you're connecting to, or the vendor, the connection string, the user that's connecting, and the statement they're running. So probably the best way to show you how to use it and what you see is through a demonstration. So let me show you a quick demonstration of that right now. Here we have a .NET application using ODP.NET OpenTelemetry. First thing we want to do is set up the OpenTelemetry tracer provider. Once we do that, we add Oracle Data Provider Instrumentation Extension method. This you will find in the ODP.NET OpenTelemetry NuGet package. What it does is it enables different attributes and be able to use OpenTelemetry with ODP.NET. With that, we will enable several features. One is connection level attributes. Another one is recording exceptions, Oracle data reader reads, and then also SQL text that gets entered. So once we have enabled those, they will get traced out. We'll need a place to output those traces. So we are using the console exporter, which is another NuGet package. Now that we've set things up, let's create the actual activity source, and we create a new one here. So now that we've done the setup, let's go to the main part of the application in the console app. First thing we want to do is set up the connection. Then we want to set up the command, open the connection,
We then provided a command text, select start from employees. And then to start OpenTelemetry outputting, we have an activity we register. So we're using an activity source, and we start the activity and we'll call it retrieve data. And once we do that, that activity will be traced, and then we have the statement executed, read the data, go through it, we'll dispose. Let's see what gets output in this ODP.NET OpenTelemetry trace. So we're going to run the app, and we're going to see the results. So here we see that it's run. Go to the top. We see that we have ODP.NET as the activity source name, and display name is send execute request. It provides us some trace level information, such as how long the activity took, when it started, and then some ODP.NET specific information that we've tagged in our provider. Things like you're connecting to Oracle, what is the database name, what is the connection string without the password, what is the user that's connecting, and what is the statement being executed. That was the send execute request. We have our execute reader activity here that we're monitoring. We see how long it took, and the same information in tags that was seen before in the previous activity. And then the next activity we have is the read activity, and it provides similar duration and tag information here. And then finally, we see the retrieved data that we created in the application itself, and we can see how long that activity took. That, in a nutshell, is how to use ODP.NET OpenTelemetry and some of the information you can collect in the traces.
So let's switch gears a bit, and that was .NET's ODP.NET's implementation of OpenTelemetry and support. Let's talk about JDBC. With JDBC, what we have is OpenTelemetry support as well in 23C. In this case, where there's no direct implementation of OpenTelemetry in the driver, Oracle JDBC provisions a hook for third-party observability frameworks. So what we're doing is we use the OpenTelemetry instrumentation for Java, and you'll find that in the link there in that tiny URL link. And that third-party library has been instrumented for JDBC and has a Java agent, I should say. And that Java agent creates a span for each JDBC API call. And the Oracle JDBC furnishes then a wrapper interface that A, creates a before child span of the parent span created by the Java agent, then B, makes a JDBC call, then C, creates an after span of the parent span created by the Java agent. That's what it does in a nutshell. And in order to use it, you implement the wrapper interface. You start with the Java application and the Java agent, something like logging, Zipkin, Jaeger, and so on. And then you can feed it collected data with the OpenTelemetry collector. So that's how the JDBC OpenTelemetry works. So we got a bit about OpenTelemetry and learning about that observability framework and how it integrates with Oracle Data Access with your database. Let's talk about tracing. And this is when you use tracing, and specifically with Oracle JDBC or ODP.NET, you're getting more fine-grained traces than, say, with OpenTelemetry. OpenTelemetry kind of collects a unified trace for a lot of different components. And if you need to dive deeper down, you want to use the tracing for your specific client provider. And we want to talk about some of these specific attributes to help make your tracing much improve your experience with it. So that's what we're talking about here. In ODP.NET's case, we have the ability to dynamically trace, which allows you to turn on and off tracing at runtime. And this can become important if you have a problem that you want to trace, but only occurs after, say, 5-10 hours of operation, or only occurs after some trigger that you know happens, but may occur intermittently. So this provides a way to keep your trace file smaller and more compact, and it also limits, how big you have to share your trace file with, and how much and what data is in that trace file, since you can turn it on and off as needed. And in order to enable it, you set this Oracle configuration trace level attribute or property to the trace level you want, and that will turn on tracing. And then when you want to turn it off, you reset it back to its default value. And then if you can also limit the trace file size itself, because sometimes you do need to generate gigabytes of trace just to capture all the data that's going in. Maybe you're measuring something over long periods of time, but you don't want to have a gigabyte file in order to open. So you can break it up to say, I only want 200 megabytes for my maximum file size, and OpenTelemetry will then trace only 200 megabytes of data and then start a new trace file for the next size for the next set of trace file data instead of just writing to the same file continuously. And in terms of securing your trace file, if there's operations you don't want captured in it, because it is writing to a text file, things like the SQL that's being written or the network data that's being transported back and forth between the server, you can limit uh, that trace in there. You can tell ODP.NET, don't trace the SQL, don't trace the network packets, and that will further reduce the amount of trace that you have, and also of course make it more secure for your uh, be able to share that trace file with others if those are in your organization or outside your organization. And to enable that, you use this Oracle configuration trace level and set it to 15, something like 15. It's actually trace level 8, but usually when you want to collect more trace data, you're going to set it to something like 15. And then for JDBC, we offer dynamic and secure tracing with Oracle JDBC as well. So you'll be able to have two methods to generate debug tracing for public and sensitive data. And that type of trace that you have is in public mode. They don't record or persist any sensitive information. So this reduces the amount of data captured but limits the effectiveness of the features. And in the sensitive mode, these features are recorded and persist inside the trace file. So Java developers can share those trace files with the redaction of sensitive data. The sensitive mode can be enabled only by a privileged user. So there's two switches. One is that enable sensitive diagnostics, set that to true, and permit sensitive diagnostics and set that to true. And then in this sensitive mode can be enabled, disabled programmatically at runtime or via MB. So that was our presentation on using our collecting diagnostics, telemetry, and tracing with Oracle database and developing with Oracle database. We covered a lot of the technologies that JDBC uses, as well as technologies that .NET uses. Those topics are diagnose on first failure, OpenTelemetry, and dynamic and secure tracing. We hope that you're going to check these out and use them in your applications to better improve their operations. And good luck coding. Thank you.
Thank you.